Hey everybody, nice to be here. Always nice to be just behind Erich and before the lunch, so I'm splitting you from the lunch now. I think I have 8 minutes for my presentation left. So I try to speed up, but I cannot promise I will hold it to the lunch. Sorry, Erich. But perfect.
A lot of content.
Yeah, nice content. I'm very happy to be here. Just once, first of all, I'm Arno. I'm very happy to be here. I'm one from Fraunhofer. We are building up 2 factories right now for battery cell production. This is, so maybe some people heard about Fraunhofer. Inside Fraunhofer, we are special because we build up the factories and we operate those factories, meaning we have a deep own requirement of having a good level of digitalization and also for the operation phase, including OPC UA in there. So I will talk a bit about battery cell production. And so just one question from my point in this direction, in this whole audience here. Who is an expert in battery cell production or is producing machines for battery cell production right now? Nice, perfect. Then you're a perfect audience for me. Afterwards, I ask again, and hopefully most of you will tend to, okay, now I want to produce something. Okay, so just some basic introductions because the question came up yesterday multiple times and today already sometimes. Currently, there's some noise in the media regarding battery cell production, battery as a whole. So you see often in the newspapers something like Northvolt bankruptcy and more. You heard about that. And of course, we are in Finland right now. I'm not aware of a gigafactory manufacturer of battery cells right now in Finland, but I know there are multiple big companies dealing with, for example, the recycling, for active materials, critical materials, and more. So maybe in the first glance, you may think Finland is not the main audience for battery cell production, but I can assure you, Finland is very, very active in this whole field. So, and for all what is going on in out there in the media, just keep in mind there's no black and white, and battery cell market is growing. So you want to be in there, and it's cool, of course. Yes. So don't worry, this is not exam relevant. In that case, if you think of battery cell production in here, you see there's a very long process chain with many different steps in there. And of course, you see there's electrode production, cell assembly, and cell finishing steps, including the electrode production also have to be done twice because we did once for the anode and one second one for the cathode in there. And you see so many different process steps, and some of them are already something you heard about. So think about something, the mixing. You may already think about, okay, there was some extrusion mixing, for example, injection molding machines with twin screw extrusion machines. So something is ongoing there already, right? So something has to be standardized there already. And this is one of the key points in here. We have multiple process steps in here, but some of them are already standardized from other domains. So one of the key points we want to take in here is, okay, we want to reuse everything that's existing there. We do not want to reinvent the wheel every time, so let's reuse everything that's existing there. So if you have something ongoing right now with some of the machines, maybe something to those process steps, welcome to the battery world. Yeah, keep that in mind. So, and we have some topics of fast innovation and knowledge gaps. I'll give you 2 examples. So one thing is, if you think of a coating machine in battery cell production, if you're in industry scale, you're something like 80 to 100 meters per minute production. So after the coating machine, there's a 80 to 100 meter drying oven inside a dry room environment. You can think of that's horrible in terms of the space you need, and it's horrible in terms of energy. So if we now have an innovation with laser drying, we cut off this 80 meters, so it's really deep impact on my whole production line. We can have this also for dry coating, where we can skip multiple steps at once. So you see multiple innovations are happening right now, and these are 2 examples of more than 100 ongoing right now, and we face in the next 10 to 15 years. So you see so much is ongoing in there, and this is not like a fixed production line in other domains where we have more fixed for the standardization. So for standardization, it's more like a nightmare, since every week something is happening and something's changing. And the other part is being about knowledge. So if you think of a milling machine, for example, milling process, you find experts out there that tell you, okay, these are the key relevant parameters, the key cause-effect relationships, and they are always more or less the same. They answer you. If you go to battery industry, everyone has their own opinions, maybe changing week by week. So you see so many different requirements and also challenges we face in terms of digitalization and digitalization. This was the first, the fast step around battery cell production. So now we come to the regulation part. Just beware, I'm not a lawyer, not a lawyer, I'm not a law guy, so please, if you want to have correct wording for a law person, please go to a lawyer. But still, the motivation behind that. We have battery cells and we have several critical minerals. For example, we think of lithium, cobalt, nickel, manganese, carbon. All of these are critical. These are critical resources, they are very expensive, and the EU says, okay, we want to have a circular economy, so we need our supply chain to handle that. And this was one of the key motivations for the battery passport we come to in a minute. But the key motivation then is, how can we recycle and bring back that into our own production of battery cells? And you see, this is where we come from. And so the first step was, there was a first regulation, it came to place. So many points up there, CO2 emissions and carbon footprints, Eric already told about you. And of course, there are topic of recycling. So these are the main motivation parts. And you see, something was ongoing and it's already validated last year. And now, so many different topics in there, I skip over that. But the major time frame you should be interested in. So many texts in there, you can read afterwards, but there's one key point in here. Erich already mentioned, there is something ongoing and it's already in place. So it's mandatory already with certain time frames what to happen when. And you see, by beginning of next year, you as a manufacturer of batteries have to have the availability of some data at your site if someone requesting it. And at the beginning of 2027, there's a digital battery passport with a QR code on your battery cell being mandatory. If you do not have that, you will be fined for the whole EU. And this does not only hold for you, the battery cell manufacturer, it also holds for you in the case you have a product where the battery is inside. Of course, you have to link to, okay, where's the battery passport for that? And there will be one major point on that we'll see afterwards. And first of all, the question often arises, which batteries are relevant for that? Every battery that's more than 2 kilowatt hours in size. So this is not something in your watch, but of course something in your car, something in a light vehicle, also some of your power tools from a certain degree. E-bikes, very hot topic right now, of course. Sometimes they have very special battery cells in there with special formats, but still, they are also often upwards the 2 kilowatt hours threshold. So you can think of so many different systems. We have batteries in there, and we need the battery passport in there. And so going over that, now the EU typically comes in place how EU is working. So we have now the role that it's mandatory to have the battery passport in here. But the regulation only says you have to have that. The regulation does not tell you how to do it and what has to be in there. Yeah? So just regulate, afterward then look about what is going on. So this is what is going on right now. So on the one hand, there's currently a DIN specification, which is not a final standard, but it's the draft for a final standard, so to say, where we have now the relevance of, okay, which required data is there. Currently in the spec, there's roughly below 100 parameters, but there's some more ongoing that should be added in there. And it's going, of course, several people out there are working on that and how to manage battery passports. So this is the motivation we see, okay, this is ongoing and several solutions are in work and development or being provided right now. And this, also one of the addendum that often comes up in the first idea of the battery passport, it was excluding the use phase of the battery cell. In the later iterations, the use phase was part now again of the battery passport. If you can think of, if you have your own production, tracking data from the production is more or less easy, so to say, but it's mostly about static or slightly dynamic data based on links to databases with LCAs and everything like that. But of course, the use phase, it's highly dynamic, it's highly of interest, how to manage that. So very many open questions in that part. But still, for the second use, for example, it's very relevant because if you can think of having one vehicle with battery, a racer, for example, that's often going full speed with the battery, giving it to the limits, the battery, this battery should be recycled afterwards. Another person maybe has a battery that was used only slightly, so it's still very nice, but it's not that great in recharging. So maybe we can use that again just for stationary storages. Yeah. So for second use and second life and recycling, we want to have the use phase data to decide what to do with that. This is one of the key ideas behind. So, and now for the current challenges. Two things are especially interesting in here. So the one part, as I mentioned, we have a regulation, but we do not have the information of what is exactly needed and how in there. So this is still a question. And to remind, this is roughly 1 year still until it's mandatory. So many time left. And the other part, of course, so most of the total implementation that's going on right now is about the data management task and questions. And this leads to, there's a variety of people out there creating their own solutions for a battery passport. And of course, they're doing it often on their own. And this brings us to the role of OPC UA in that point. So, just to recap, for the state of interoperability. So, on the one hand, we have a high innovation frequency of equipments and recipes. For example, maybe you heard also in the media, there's one lithium-ion batteries, then there are some upcoming with sodium-ion batteries, and of course there are all these solid-state batteries, like the holy grail everyone is talking about. And for 40 years now, everyone tells you in 10 years they will be there. So this is something very much ongoing. So we have long-term fixation in terms of authorization approach. We have a low level of the known cause-effect relationships. So our parameter sets are often changing step by step, week by week, month by month. And also, several of the providers of the machines for the battery cell production do not know the perfect links of those themselves, because often, or most of the cause-effect relationships do not play internally in their own machine, but in the interchange with all the other machines in the whole chain of the process. So very complex. Of course, we have the recycling, as I mentioned, so we need an interaction along the whole supply chain also. And of course, we have the external regulation, but not a defined standard. So, and of course, maybe you heard something from Steve, for example, and Erich, something like cloud and modern production, maybe something with data also in there is required. So, to handle all of that, what we really need is the interoperability as the key, and we can use the OPC UA as the resource for that. And so we have two actions right now ongoing to tackle that topic. The one part, I think Stefan mentioned it in the beginning very shortly with one sentence. There's an ongoing joint working group where it's dealing just with the battery production line and focusing on, okay, how can we standardize the parameters that are ongoing in there in my whole production line and deal with them. There was some weeks ago, there was the first draft of this competitive specification available. One major part in that, and this is very crucial for that, it's not about creating a full-fledged competitive specification from scratch and everything from new, but it's often they call it the meter standard, because in many cases it's just looking for, okay, which are some parameters other domains already looked into in deep, and we can reuse that. The typical example, as I mentioned before, there was this twin screw extruding machine, right? So of course we have the Euromap guys, and we have the competitive specification for the plastics and rubber. They did really great work on that. Why should we reinvent everything of that? Just reuse that and reframe it just for our battery case. Yeah, this is the key idea behind. So this is the key not only for interoperability but also harmonization with each other. So this one is active for I think 1.5 years now, and the first draft some weeks ago. And the second one, it started I think 2 weeks ago, and this is about the battery solutions Stefan mentioned. First, aiming for the battery passport as a first case inside there, and we'll go into deep for a second. Meaning, if you think of the battery passport solutions, currently you go out there, you look for that. I don't know, is there someone from Siemens in this room? Okay, then I can be open on that. So there are so many solutions out there, so many in development. So Circular has something, the CCPAS consortium, they are working on something. IDTA has some ongoing work on that. They also provided or said by end of year there will be a new release of everything. Catena X was already mentioned. Of course, they have several works on that, but they're focusing especially on the EV part. So for the vehicles, not for example for BESS or the battery electric storage systems. And of course we have partners or industry partners like, let's say for example Siemens, that maybe not only having one but multiple solutions for the same problem. So you see so many solutions are out there or ongoing, but in practice, you want all of them to be interoperable because you need the interaction along the whole supply chain. And this is what we are aiming for. So you see different technologies also in use. In this group, we just do not want to create the next battery passport definition because there are enough out there. Please, we do not want to do that. But we want to have an interoperability layer, how to interact with all of them and make them interoperable with each other. And also look into, okay, so if I, for example, connect the Circular with the Catena X with a Siemens battery passport, is there maybe something somewhere, a behavior that's missing or a change in behavior? So we can tell them, okay, so this is in that point, you're not consistent with each other. Yeah? But still, we're using OPC UA. We try to bring up the interoperability layer and also, for example, looking for different domains. Currently, it's very dominated by the EV industry, but we also look into, for example, what about BESS? Yeah? So this is what's going on in there. So if you have anything to take from this talk right now, please take home two things. The one thing is we do not reinvent the battery passport. Please, we do not do that. And the other part is battery cell production is great. So these are the things. And one last slide from my side. So inside this battery solutions working group, we just started, so I have not the detailed intake, finalized result slides as Erich did, but just for our approach in here. We do it on a split fold. So on the one part, we are just starting with the first case, with the battery passport, as I mentioned before, looking into what are different solutions, how we can create the interoperability with that. And the other part is we are just continuously ingesting what are other solutions that may be having the same problem, with us just arising right now because of the multitude of battery cells out there and the different productions. So these parts we are doing right now. So I cannot tell you what's the next case after battery passport, but I can assure you battery passport itself is not a small case. So we have to do much work on that, and we're happy with that. Yeah. So this is what's going on in there. And as I said, key messages for today, battery cell production is great. We are not reinventing the battery passport, but we want to make all the things, the battery solutions being interoperable. And by that, I hopefully can enjoy with you some lunch afterwards.